Hi, I'm Dr. Dan. Welcome to another YouTube tutorial on Unity and artificial intelligence. So today we are going to code behavior trees. So I'm just going to start with a new project. Behavior trees are a way of implementing AI, kind of like how state machines are a way of implementing AI, or goal-oriented action programming is a way of implementing AI. And for behavior trees, the AI is implemented as nodes in a tree that it goes through in sequence. So that tree can be very deep and very complex if you want, or very simple. So they're a very flexible way of implementing AI. You'll get to know how that works as we go ahead and implement them. So first, let's save this scene as behavior tree, whatever. Let's add some things that can have a behavior tree first. So let's add a plane to walk on. The behavior tree will implement, it will be an AI that plays tag with us, and we'll add some obstacles so that we can hide from the AI, and he does a different type of behavior than when he can see us. He goes and looks for us, and he does a different type of behavior when he's when we've tagged him, then runs away from us than when he's not it. And you'll see how you can make fairly complex AIs this way. So let's make some obstacles here. Oops, one is good for that. Maybe 3, so there's a nice wall. Maybe even 4. 3 is probably good. All right, so let's make a empty game object to hold our obstacles. And we can duplicate this, duplicate it a couple times. Let's rotate one of them 90 degrees and make it over here. Duplicate again, pull it out over here. Okay, so that should be enough to just get started hiding. The other thing I want to do is let's just make a new material for our ground so we can see the ground's different than the walls. Something brown is probably good. There we go. Now in assets, let's import some characters to work with so we can so we don't have to code those from scratch. This is a tutorial on behavior tree implementation, not on making a third-person character. So I'm just going to grab all the third-person characters from standard assets, and I don't think I need rollerball either. Okay, let's import all those. Okay, so now in standard assets we have our characters, third-person character, prefabs. Let's drag a third-person character onto the scene. One that's AI, this one right here, and one that is a normal controller. Okay, so right away we should be able to see that our normal controller, oh, we're getting an error. Our normal controller can move things around, but the game camera is off and staring at a wall, looks like. So let's fix that. Let's add a script to the main camera that just makes the camera follow this game object. So we'll just grab the transform and walk around with it of the third-person character. So to do that, I'll have a public game object player and an update, and a vector 3 offset. So we're up and back a bit. And that'll be at 0f, 5 on the y-axis, and -5 on the z-axis. So back behind the player a bit and up. And in update, we'll say transform.position. Remember, this is on the main camera, equals player.transform.position plus offset. And since this is happening in update, we might want to check if player does not equal 1. Okay. So back in Unity, let's save this and drag our player, which is our third-person controller, over here, and let's run it. All right. And now we can move around. The camera is still way up there. So let's see if we can just rotate that down. Maybe like 20, 30. That looks good. Okay. So let's just keep the main camera rotated at 30 here and save. And that will give us a nice camera follow there. Okay. Now we're getting an error. Get remaining distance can only be called on an agent that has a nav mesh. So let's select the plane, select navigation. If you can't see that, go to Window, Navigation down here. And let's click Navigation Static and make sure Walkable is selected and bake. And then let's put these walls in our obstacles. Select them, select Navigation Static. These are not walkable. And let's bake those as well. All right. Now, just to get our AI started and make sure that it's working, let's give this third-person controller a target as the player. And let's just make sure that it runs over to the player, and it does. Okay, cool. So that's all set. We're not getting any errors. Now we can start coding our behavior tree.
Okay, so first, we can just click here and click on create, and then if I, oops, nope, I don't want a XML. If I click create, and I'll have to actually scroll down a bit if I can. Having trouble with my screen. So you have to scroll all the way down. Let me pull this up, maybe. You have to scroll all the way down to make a Panda behavior script, and because of the way my monitor is set up, it's not letting me do that. But let's see if I can just... No. That's good. Don't want to be sharing right now. All right. So I'm actually going to drag this over. I'm using dual monitors. I'm going to drag it over. You won't be able to see this part, just to create a Panda behavior script. Oh, that's why. I haven't added them yet. Wow. All right. So let's go ahead and... so the type of behavior tree we're going to use the implementation. We're not going to code it from scratch. It's a fairly involved process. Instead, we're going to import our from the asset store, Panda behavior trees. So let's just go to the asset store. This is a free asset. It's available to everyone. So now let's go ahead and grab that. So you'll see that there is a free and paid version. We want the free one. Paid version's not too bad. And there are many types of behavior trees that you can get. And some of them you can, in the editor, just drag and drop nodes. At some point you'll have to actually code the root nodes, well, depending on the behavior tree you get. But we're just going to use Panda behavior trees because you'll be able to understand how the code communicates with the behavior tree and so on. Alright, so in Panda behavior tree, take a look at their examples. They have a nice play tag example. We're going to implement something similar to this. So you'll see we have a square that runs away. We tag it and it tries to get us. Okay. And if you take a look at the computer, there is this behavior tree right here that you can see those nodes light up as certain things happen. Okay. Examples are pretty well documented, and I invite you to go through them. They go from the very simple ones to very so this one, we just have a cube, and you can see we have a sequence with a weight, and it's just setting the color there. All right, back to our scene. Here, and switch to our scene view. Let me just align the camera with view. So game object, align with view, so we can just, all right. So on our AI third person, we are going to add a component here, which is going to be Panda behavior, and that needs a PandaBT script. Well, this is what I was trying to do. Create, and then, like I said, you have to scroll down an PandaBT script. And let's see where that showed up. Oops. Where did I put that? Interesting. They are disappearing. Let's create. I'm having trouble with this. Very strange. All right, there's our script. So this is just basically it with the BT extension. So let's call this AI.t. Call it, and what matters is that the Panda behavior knows about it. So let's just drag that over there. Okay, and we have a tree. We can open that up in the editor. Visual Studio. Things don't crash. There we go. And you'll see we have a very basic tree. It just succeeds every time. So every tree begins with a root node, and then under that root, the different nodes that behaviors will follow. Okay. Let's switch back to our script. So Panda, the way that it works is that it looks for tasks. So we're going to decorate our methods with an attribute called a task, and a node, the name of a task. It'll go and execute that task. So it'll execute the function. So we need to add an AI script. Let's call it AI tag. Let's bring that over a bit. Let's edit that. All right. So this is going to be our script that the PandaBT text file communicates with. So we need to do a couple of things. First of all, we need to know about our own nav mesh. So let's use Unity engine.ai, and now we can call agent. We're also going to need to know about the player position. We'll need a float for our vision range. We can set that to like 20. And we'll need a Boolean. Are we it? Alright. And start, let's hook some of these up. It's just going to be our own nav mesh agent. And our player. We could hook this up in the editor, or we could just do game object, find objects, object with tag, player. We just have to remember to tag our player as player. We'll say, is it in tag? Initially, we'll make that true. And because that's true, let's turn our, let's make a method. Turn color, and we can feed in color red. So we'll keep track of whether we're it or not visually with what we've turned red or, I don't know, blue. All right, so public void, red or green, how about that? We'll take a, and it will turn color. It will get all of the renderers underneath renderer. Get components in children. So we'll render components that are nested in this third-person character, and then we'll do a for each loop over them and say for each renderer we'll set our material color to color that we pass in. Okay. The other thing we can add that doesn't really have anything to do with Panda behavior trees is on collision enter method, where we say if collision, so if we've collided with the player, so if the tag equals, then we can ask, hey, are we it in tag? Oh, we want to be the opposite now. right? So we'll switch that Boolean, and then we'll say if we're currently it, then let's, what did we call that method? Turn color to color.red. Else turn color to color.blue. All right, so to do with the tag logic. So now using the behavior trees, we're actually not going to use the update method because the behavior is going to be ticking every frame, so it'll handle our update. So the first thing we need to be able to do is go to desk. So let's have a task. So that task decorator isn't getting picked up right now. And that's because we need to be using the Panda namespace. So once we're using the Panda namespace, this is a decor. It is this is an attribute. It functions like a decorator. So it's making this next method have a that Panda can pick up as it parses through the AI script. So for to a destination, whether it's the player or some random place, we'll just say if agent.remaining distance. This is just a variable of the nav mesh agent. So if it's less than or equal to our stopping distance, and we're not looking for a path, we're not calculating the next path, then in the task.current.succeed. So each node in a behavior tree returns failure or running, and so what we're going to do is we're just going to say we succeeded when we have arrived at our destination. Otherwise, we won't get out of this method, right? It'll keep trying to get to its destination. All right. The other thing we can do is make a task called target player. And in that task, we'll just set destination to our player's transform.position. Succeeded. Task.current.succeeded. Finally, we'll want to know, are we it? And, for this, we're actually going to just return a Boolean, and it can be a private method. So we will return is it in tag, and our current status there. So if we are it, we want to go to the player. If we're not it, we'll by targeting the player and then trying to get to it with these two methods. If we're not it, we need to run away from the player, the method for that. Run away. Let's make a vector3 called away vect equals our transform position minus the player's transition. And let's make it a bit bigger. So times equals 2, and then agent set destination to that vector. Finally, And actually, we're not really running away yet, because we'll need to go to that destination. So, runaway, set runaway destination. Okay, so if we're not it, we'll turn green and we'll set the runaway destination. All right, over here in our AI now, instead of having succeed here, let's make a let's say while is it. So is it, remember, returns Boolean. It's just gonna check if that is true. And let's make a fallback. We can make a tree here called chase player. And then, chase player. And then let's define that tree down here. So tree chase player is going to be a sequence. And so we'll first target the player, and then we will go to our destination. And while we're at it, let's go ahead and make another tree, which is run away. It's going to be a sequence that, what are those methods called? Set runaway dest, and then go nation. Set runaway dest. Actually, we need this to be a fallback. So fallback is a type of sequence node. Sequences just run in sequence, but it allows these nodes underneath to fail. So I want to be able to fail when I'm not it, so I can get to while not is it. And we'll have a tree which is run away. Okay. All right. That should be good, but it probably isn't. Let's see if it at least compiles. It did. And we have a null reference. Path is empty. And our AI third person. So we need to drag our player game object over there. And let's run it. All right. So our AI did in fact turn red. Ooh, we lost our camera's position here. Let's fix that. And we're getting a lot of null reference errors. Right, because we didn't tag the player. So let's go ahead and tag this as player. Save it. Let's see what's going on with our main camera. Oh, we changed the rotation when we aligned with view, so let's set that back to 30. And these values will change, but the rotation will not. So let's switch over to our game. All right, it's turning blue and red. So blue still chasing me, goes to red. Now it's like flickering back and forth. All right, so we've got some problems. So let's switch over to our AI and take a look. So what we're doing is we're running through these very, very quickly. And so what we want to do here is perhaps not fall back as much as we are. So while is it, we are going to, let's just run that tree without a fallback. How about that? That's just a sequence. And save that. I think we might get an error over in Unity if I do it this way, but let's see. Okay, so the what we're doing is we're detecting let's see, we're it. And our third person, our AI, so this is going to be debugging, right? Are not it, so we should be running away from the player. So we've detected that we're okay, so let's see. I think this may be a problem with our actual AI here. So when we run away, when we set run away destination, we are setting the destination to transform minus the player and returning succeed. Okay, so I think actually we don't want a fallback here. Let's have another tree, which we'll just call select. And that tree we will have a fallback, and we'll say while is it fallback tree chase player, which is a sequence, and then while not is it, we'll have a fallback to our tree run away, which sets the runaway destination in sequence. Alright, let's save that and run it in Unity. Alright, so we're still always tracking the player. Let me get into the blue state and pause it. Alright, so we're in our blue state, and we're currently in both trees. So while is it I see what the problem is. So in our AI, remember when we were testing, we set the AI target to and that is actually overriding all our other scripts. So I'm just going to set that to none and save it. And now we should get the functionality that we want. So there's blue, running away. Okay. So what we do in fact want transform position minus our player transform.position here. That was correct. I switched that just to see if I had that vector math backwards. I do not. So there we go. Now he's running away from us. And we go and try and get near him. Okay, there's a bit of a problem because he's just running endlessly into this wall. Oh, because that cube didn't get tagged as a obstacle. Okay, so we have these obstacles, but our AI is not detecting them as obstacles. So we're going to add a tag here. To as obstacle. And we're just going to select all of those, go to navigation object. Let's select navigation static, not walkable, and bake them. Alright, and now we have an AI that kind of more intelligently runs away from us. There he is. He's pretty good at this. Let's see if we can find him. I cannot. I'm going to boost my speed up a bit. He was all the way over there. Alright. So, good. We have a game of tag now. Let's actually give him a range here, which is, well, okay, so we have a very basic AI, and two trees, right, with sequences in each tree. So now let's give our AI the ability to know if the player is in sight, and if the player is not in sight, not keep running away from them as though they know where the player is, even though they do. So we're going to kind of limit the AI to get more realistic behavior. So to do that, we'll need some more methods. First of all, let's have a kind of find the player method. So let's have a task, public void find player, or maybe like search for player. And what we'll do is actually add a parameter here. And we'll look in a random dest, which we'll set as a new vector 3. And then we can do random.range between our players transform x. So we'll look somewhere around the player. Range. We'll keep 0f on the y-axis, 0f, and then we'll do a random float, which will be our players transform z minus range. Oh, and we need, so it's a range, right? So we need two values here. Player transform position x range. Player transform x. Okay. Position dot x minus range. Same thing here. Player transform position z minus range. Player transform position z plus range. Okay, so that is going to give us a vector somewhere around the player according to the range that we send in. Okay, so we'll have a kind of intelligent search, and then we'll set our destination to this random dest. Nope. Random dest. And with succeed, task.current.succeed. Alright, so that's how we'll search for the player when we don't see them. We see the player. In this task, we will first of all see how far away the player is. So vector 3 is from player equals player transform position minus our transform dot position. And then we'll send out a raycast hit. We'll have a boolean. Can we see obstacle? Set it to false initially. And we'll say if physics dot raycast we send out from our position distance from player out hit. If we get a hit for that, then let's ask if our hit.collider game object tag is equals a obstacle. If so, we'll return return true. Well, we'll set C obstacle to true. Because we want to check for one other thing. Now we want to check if our magnitude of our distance from our player is less than our vision range, and we're not blocked by a wall or an obstacle, so we don't see obstacle. Then we'll return true, we can see the player, else we'll return false. Okay, so now we know if we can see the player or not. And the final thing, we might want to have a idle state. So if we're not searching for the player, well, let's just leave it at that. So we can search for the player, we can run for random destinations. Alright, so now over in our AI, we need to make a few changes. So we have these two trees, we fall back while we're going to chase player, but we can also search for player if we don't fall into that sequence. Actually, let's not. Let's just chase the player there. While we're not yeah, let's say make another tree which is search and do is sequence, which is search for player, and we'll pass in a range of 10, so we can wind up anywhere within 10 player. And let's just add a 0.0 so it knows it's a float. And then we'll go to our destination, and that'll be our search tree. We'll only get into that if we don't chase the player. Let's add to our chase player a check, because we want to chase the player while we can see the player. So can see player while can see player. That returns true. Then we will go into this target player go to destination sequence. So chase player now will bounce out, and the fallback, right? Instead of a sequence, we will stay in this sequence and we'll go to our search. We can't see the player. Okay. And actually in our AI, okay, so finally, when we're not so we were running away kind of endlessly last time. So while we're not we can put another while in here. First, let's do a fallback, and let's say while can see player. Then we'll do the runaway. Otherwise, we'll do a fallback while not can see player. And let's make another tree, which is idle search. So we'll have them just kind of wander, or just wander. Tree wander will be a sequence that, let's make a new method in our AI, which is very similar to our search for player method. Let's just call this wander, or find wander destination, and we'll put in a range, but we will just use that range to find a new vector instead of finding a new vector somewhere around the player. So we'll just get a random place to go, and that'll be negative. This will be negative, negative, positive, positive. All right. So find wander dest. Let's copy that and paste it in here, and then go to dest and save it. And we want that tree to be a fallback as well. Okay. That should be good. Let's switch back to Unity. And let's make a few adjustments. Our AI is a little too good at getting to us. So let's slow them down a bit. For their speed, let's set it to 0.5. Save it. And our third person, we can set this to 1.5. And we might as well set the anim up as well. Alright, so now if we play it, oh, we had an error. Find wander dest is not defined. Oh, right, because we need find wander dest needs a range. So let's give that like a big range, like 30.0. Alright. Now we should be good. So, and we can scroll down to his tree, and you can see he's saying, I'm it. So I'm in the tree chase player, and I can see the player, so I'm walking. So now let's get out of view. So he can't see us anymore. So now he's going to get kind of close to us, but he's just sort of searching for us. And he can see us again. So these walls are not actually preventing him from seeing us. Something about that. That is because they are untagged. We need to tag them as obstacles. Let's save that. And now, when he sends out his raycast and there's an obstacle in the way, you'll see he can't see us anymore. And if we scroll down to his tree, he is searching. So he's searching. He's going to try and find a destination somewhere close to us, but necessarily guaranteeing that he'll get to us. So pretty sophisticated AI. Now if we run, oops, let's run towards him so he can see us again. You'll notice that he'll still try and find his destination. Now he knows he can see us, and he is in fact us again. Okay, we've set his speed down really slow, so we're safe. So now let's let him be it. There's that little like tag, you're it, no I'm it, no you're it, no you're it kind of thing. Now we can change that with just making the obstacles collider handle a little bit smoothly. If we look at his AI tree, he is trying to run away from us. And once he gets out of sight, he'll go into this wander state, a random destination, and just kind of wander around. So there we have, and you know, of course, to make this game more interesting, there's a lot of tweaks we could do, but I want to under an hour. I hope that was helpful for you. It's how to, you know, have a fairly sophisticated AI that calls other trees. Some of those trees are sequences where each node in the sequence has to be performed, has to return in order for it to bounce out. Otherwise the sequence fails, and fallbacks where it doesn't matter if the sequence fails, the next nodes, right? So even if chase player fails, we'll still run search. And chase player is going to fail sometimes because we check for whether or not we can see. What we want to do then is fall back into the node.